All right, let's just jump right in with a big question. What if a fundamental part of Einstein's theory of relativity was wrong? Today, we're diving into a really mind-bending alternative model that suggests our whole perception of time isn't what it seems. And it all kicks off with a simple little question about a train.
So let's start with what sounds like a simple puzzle. If you're on a train that's just rocketing along at near light speed, does a beam of light travel at the same speed toward the front of the train as it does toward the back? Of course, Einstein's theory of relativity says, yep, it does. But what if the real answer is a hard no? That's the provocative idea we're going to unpack.
And exploring that question leads us to a simple thought experiment that spits out a surprisingly, well, a really lopsided result.
Okay, so picture this. You got a train and it is moving fast, like 80% the speed of light. From the very back of the train, you throw a ball forward. And let's say that ball is moving at the speed of light. It hits the front wall, then bounces right back to you. The big question is, does that forward journey take the exact same amount of time as the return trip?
Well, the journey to the front of the train takes about 50 units of time. And that kind of makes sense, right? The ball has to play catch up with the front of the train, which is constantly moving away from it. But here's where it gets weird. The return journey is just 5.56 units of time. I mean, that is shockingly fast. Why? Because the back of the train is now rushing towards the ball, so they meet up way, way quicker. That is a huge difference. In fact, if you round the numbers, it's a 9-to-1 asymmetry. The forward trip takes 9 times longer than the trip back. Now, special relativity explains this by saying that space and time themselves get all warped. But this new model, it proposes a totally different explanation. It says the asymmetry isn't in reality itself, but in how we perceive it. So, how do we solve this 9-to-1 puzzle without bending the universe? Well, this model says we don't have to. We just need to build a new geometry, a geometry of time. Instead of changing the fabric of reality, it changes how we think about perception. Okay, the first piece of this new geometry is something called the recognition sphere. Try to imagine this. You are at the very center of a sphere, but the radius, the distance from you to the surface, it isn't space, it's time. The farther you look from the center, the farther back in time you're seeing. That surface is basically a window to a past moment. And the second piece, that's the tangent plane. This is actually way simpler. Just think of it as a flat stage. This is physical reality, where all the stuff, atoms, our train, physical light, actually exists and bumps into each other. This is where cause and effect happen. So where do these two things meet? The sphere of our perception and the plane of reality. They touch at just one single point, and this model calls it the anchor of events. This is your here and now, the one spot where your physical body actually intersects with the physical world. Everything else you see, according to this, is a reconstruction of the past. Okay, so if our mind is at the center of this time sphere, but reality is happening out there on that flat plane, how does the information get from out there to in here? Well, this model has a really clever idea for that. It's called the postal ray system. To get this, we have to split the idea of light into two things. On one hand, you've got physical light, the stuff that travels on that tangent plane, the real world. Its speed appears to change depending on how you're moving. But then you have what this model calls postal rays. These are not physical. Think of them like pure information packets, like an email protocol for reality. So here's how this postal ray system works, broken down into 4 steps. Step 1, an event happens out there in the real world on the tangent plane. Step 2, a postal ray, that little packet of information, shoots out from the event. 3, that ray hits the surface of your recognition sphere. And finally, step 4, the ray refracts and sends that information straight to you, the observer, at the center. So what does all this mean? Well, a really wild implication of this whole model is that our reality, our understanding of it, isn't just one thing. It's actually built on 3 totally distinct layers of perception. First up, you have the mathematician's eye. Think of this as the God view, the objective architect's blueprint of the whole system. Then there's the recognizer. That's us, our consciousness, at the center of the sphere, piecing together a map of the past based on all those postal rays coming in. And finally, there's the body. That's our physical self, living in the here and now, just trying to survive and making split-second bets on what's real. Okay, we've got our sphere, our plane, and our 3 layers of perception. We've built the whole framework. So now, let's go all the way back to Einstein's train
and see how this new lens changes everything. Let's talk about simultaneity, the idea of two things happening at the exact same time. Special relativity treats this as a real physical thing, but it's relative to whoever is watching. In this new model, though, simultaneity isn't something that actually happens in the physical world. It's something our mind creates, a reconstruction we build after the information arrives. And this is where the model really throws down the gauntlet. It argues that Einstein's core thought experiment, the one with light hitting both ends of a moving train at the same time, is, and I'm quoting here, an impossible setting in physical reality. It's basically saying Einstein confused what an observer perceives with what is physically happening. So this model it leans into that 9-to-1 asymmetry we saw at the start. It says, yeah, of course the apparent speed of light changes. From the train's perspective, the light going to the back looks like it's going at 1.8 times the speed of light, while the light going forward only seems to be going at 0.2 c. This is a total departure from special relativity, which insists that the speed of light is always 1 c no matter what. And that right there is the fundamental difference, the big fork in the road. To solve the puzzle, special relativity warps the very fabric of space and time to keep the speed of light constant. This new model says, no, let's keep physical reality simple. The warping isn't out there in the cosmos, it's in here, in our perception. Which leaves us with a pretty profound question to chew on. Are the physical laws we've discovered, are they a true description of an objective external reality? Or are they just a really, really good mathematical description of our own perception? This model suggests it's the latter. And if that's true, well, it forces us to rethink not just the nature of time, but the nature of reality itself.